Hi. Now, today we will start with a new chapter, chemical bonding. Right? We have been introduced to this chapter before also in class 10th, so we are little clear with the concepts of chemical bonding already. Right? So now, after we have studied structure of atom, right, in class 11th, right now after that chapter of structure of atom, now we are clear with the electronic configuration, how to write electronic configuration, especially in terms of orbitals, spdf orbitals, right, should be clear with that, right. And now we are clear about the structure of atom based on the wave mechanical model, right, that each orbital has two electrons and there is a positive nucleus in the center. It has protons, it has neutrons, right, and these electrons are moving around the nucleus in probable regions called as orbitals, right. Now the next thing that comes to our mind is, now we are clear about the structure of atom. Now the next thing is, let's look at the molecules, right. In molecules, if you see the molecules, in molecules atoms are combined, right. Take any molecule, take oxygen, take nitrogen, hydrogen, or other inorganic molecules like sodium chloride, calcium chloride, zinc chloride, right. In all these molecules, these atoms are combined, right. And the other thing that we need to see is, that some atoms like helium, neon, argon, krypton, right, all these can exist independently, right. But if you look at this oxygen, right, nitrogen, hydrogen, all these does not exist independently, right. No independent existence. Right, these can exist independently, right. And why atoms in these molecules can combine? Why are they combining? Right. So here, why atoms combine? Right. And why, the other thing that comes to our mind is why H2 is possible but H3 is not possible, right. Or why He is possible, He2 is not possible. These kind of combinations, right, between atoms. These are combinations between atoms. Why certain combinations like these are possible, why this combination is not possible, why it's He2, why He2 does not exist, why He can exist independently, whereas N or O, that is oxygen, nitrogen, hydrogen, does not exist independently, right. Why they cannot exist independently, why these can exist independently, right, and why atoms combine in these molecules, right. So different theories were put forward, right, for the reason for these chemical combinations, right. And one thing before we start, we are understanding chemical bonding, right. So what is a chemical bond? Bond literally, it means, the meaning of bond is force, right. So this is a chemical force. Chemical bonding is a chemical force, and that holds, how to define it, that holds atoms together in a molecule. Okay. For example, hydrogen, oxygen, NaCl, CaCl2, right. So all these are the what is represented by dash is a chemical bond, right. So this is a chemical bond, right? This is a chemical bond that holds these two atoms of hydrogen together in the hydrogen molecule, right? This is a hydrogen molecule, right? So this chemical bond holds these two atoms together in hydrogen molecule. So how to define a bond? A chemical bond, in whichever molecule you take, is a force that holds atoms together in a molecule, right? Because if you just look at it in simple ways also, this is the molecule of NaCl, right? In that contains a atom of sodium and an atom of chlorine, right? Similarly, zinc chloride contains two atoms of chlorine, one atom of zinc. So there is something that holds all these atoms together, right? That is a force which we call as chemical bond, right? Now we will be looking into the reason for chemical bonding, right? The reason for all these combinations that we discussed and certain combinations that are not possible. So various theories were given by different scientists at different times, right? So the theory that was accepted was the theory of Kossel and Lewis. Right? Theory of Kossel and Lewis was accepted in 1916. Right? They developed this theory independently. Now look, and based on this theory, we answered the reason for chemical combination. Right? So what is the purpose of this theory? This theory is used to look at the cause of chemical combination, right? Here the chemical combination that is occurring between atoms, the reason for that is given by Kossel and Lewis theory, right? And what Kossel and Lewis did, they studied helium, they studied noble gases, the inert gases, right? Because we know that inert gases do not react with one another and with atoms of other elements, right? So they looked into the reason for their non-reactivity, why they are not reactive, right? Why they don't react among themselves and with other elements as well, right? So if you look at these helium, neon, argon, krypton, xenon and radon, this has 2 electrons in its outermost shell, whereas the rest of the helium noble gases have 8 electrons in their outermost shell, right? So this is your octet, this is your doublet. Doublet means 2 electrons, octet means 8 electrons, right? So electronic configuration is 1s2, 1s2, 2p6, 1s2, 2p6, 3s2, 3p6, right? This is the electronic configuration of these gases. Right. Similarly, if you look at the electronic configuration of krypton, I am just writing the outermost now, 4s2 4p6. For xenon it's 5s2 5p6. For radon it's 6s2 6p6. So what we notice that all these noble gases have 8 electrons in their outermost orbit, whereas helium has only 2 electrons in its outermost orbit, because helium has only one shell, right? So one shell means, by one shell we mean n is equals to 1, so L is equals to 0 to n minus 1, which is 0, right? For L is equals to 0, we have only s orbital, only one orientation, one orbital, and we know that one orbital can contain maximum of 2 electrons, so it has only 2 electrons, 1s2. S represents the orbital, so s orbital has only 2 electrons. So their theory, Kossel and Lewis theory, is based on the electronic configuration of these noble gases, right? And they found that all these noble gases have 8 electrons in valence shell. Valence shell is the outermost shell, right? So all these have 8 electrons in their valence shell. All these noble gases have 8 electrons in their valence shell, and at the same time all these gases are found to be stable. That is, they do not chemically react with other atoms. right? They have 8 electrons in their outermost shell and do not react with other atoms, right? Whereas if you look at the electronic configuration of hydrogen, it's 1s1, right? That of oxygen has how many electrons in its outermost shell? It has 6 electrons, right? So its electronic configuration is 2s2 2p6. This is outer electronic configuration. Kind of this. So basically it has 6 electrons in their outermost shell. It has 1 electron in its outermost shell. If you talk about nitrogen, nitrogen has 5 electrons in its outermost shell, right? And if you look at these molecules, sodium chloride, sodium we know has 1 electron in its outermost shell, chlorine has 7 electrons in its outermost shell, right? If you look at calcium chloride, calcium has 2 electrons in its outermost shell, chlorine has again 7 electrons in its outermost shell, right? So all these atoms does not have 8 electrons in its outermost shell like these noble gases, right? Like these noble gases which are unreactive. Why they are unreactive? Because, okay, we'll just look in a moment. These are chemically unreactive, right? They do not react with other gases, or the atoms of other elements, or among themselves also. But these are found to react with other atoms. What the difference was found in their electronic configuration by Kossel and Lewis. All these noble gases have electronic configuration, have valence shell electronic configuration of this type, this valence shell electronic configuration. All noble gases have NS2 NP6 type electronic configuration, right? Due to which they found that these are unreactive gases. They do not chemically combine with one another, right? Because they all have 8 electrons in their outermost shell, right? Only helium has 2 electrons in its outermost shell. But these hydrogen, oxygen, nitrogen, sodium, calcium, all these were not found to have 8 electrons in their outermost shell, right? So what they do, they try to become like these noble gases, right? So in order to become like these noble gases, they will exchange electrons among one another, right? So that they can become like these helium, neon, argon, krypton, xenon, radon, right? And acquire 8 electrons in their outermost orbit, right? So basically, why these are combining with one another? So that they can become like noble gases and become stable. Why these do not react with one another? Because, okay, noble gases do not react because they are stable, right? Due to 8 electrons in their valence shell, that is outermost shell, right? So these are important points for chemical combination. And why these are combining like hydrogen? If you look at this hydrogen molecule, hydrogen atom does not exist independently, right? Like helium or neon. Whereas hydrogen molecule can exist independently. Why? Because in this, hydrogen has 1 electron in its outermost, how the hydrogen atom has only 1 electron in its outermost shell, so it will try to become nearest helium like atom, right? How it can become helium like atom? By acquiring 2 electron in its outermost shell. So what it will do is, 2 hydrogen atoms will come close to one another, then they will share one electron. They only have one electron. So both hydrogen atoms will share their one electron. So if they will share their one electron, now this also has two electrons and this atom also has two electrons. That means they have acquired doublet. Doublet is two electrons. So now, since in hydrogen molecule both the hydrogen atoms have stable electronic configuration, hence they are stable, right? Hence hydrogen molecule is stable, right? Because atoms that are there in hydrogen molecule has noble gas type configuration. Since they have noble gas configuration, both the atoms in hydrogen molecule has noble gas configuration, so they can exist independently in hydrogen molecule. They cannot exist independently on their own. That is, this hydrogen atom cannot exist, but this hydrogen atom can exist independently in hydrogen molecule. Why? Because in hydrogen molecule it has two electrons in its outermost shell. Now let's look at other example. Oxygen. Oxygen has 6 electrons in its outermost shell. 1, 2, 3, 4, 5, 6. Similarly, so since it has 6 electrons, so it cannot exist independently, right? Because only those atoms that have 2 or 8 electrons, as per Kossel and Lewis, they can only exist independently. So what they will do is, since it cannot exist independently, so it will combine with other oxygen atom. Like this. So both oxygen atoms will share their 2 electrons and will acquire 8 electrons. This oxygen atom will share 2 of its electrons with this, and this will share 2 of its electrons with this. So now 1, 2, 3, 4, 5, 6, 2 shared pair of electrons, 7, 8. Similarly, 1, 2, 3, 4, 5, 6, 7, 8. So both oxygen atoms in oxygen molecule now has 8 electrons each, so they can exist independently in oxygen molecule. Right? So oxygen molecule that contains oxygen atoms, both these oxygen atoms has 8 electrons in its outermost shell, so they can exist independently in oxygen molecule, whereas oxygen atom has only 6 electrons, so it cannot exist independently, right? So here, by sharing of electrons, both atoms have acquired stable electronic configuration, right? Now let's look at the other example, sodium chloride. We know that sodium has 1 electron in its outermost shell, chlorine has 7 electron in its outermost shell. So what here it will happen, here sharing will not take place, right? Because sodium has 1 electron that it can easily lose, and the shell which is before the valence shell of sodium has 8 electrons in its outermost shell. So, right? So it will lose its 1 electron, will transfer it to chlorine. When chlorine will accept the electron transferred by sodium, it will have 8 electrons in its outermost shell. Now this has become sodium ion. Since it has lost an electron due to deficiency of electron, this will become sodium ion, right? It has 8 electrons. Now chlorine, after accepting 1 electron, will become excess in electron and will acquire a negative charge, right? And that has 8 electrons in its outermost shell. Now we see that in sodium chloride molecule also, sodium ion has 8 electrons, chloride ion has 8 electrons. So these ions are, the electronic configuration of these ions is same as noble gas configuration, right? So both these ions have stable electronic configuration of nearest noble gas. This is how we say it, nearest noble gas, right? So these are stable. Sodium and chloride ion, sodium and chloride are stable in sodium chloride molecule, right? And like we said, chemical bond is a force. If you look at the force, the sodium ion is positively charged, chloride ion is negatively charged. So we have electrostatic force of attraction, right? There is an electrostatic force of attraction between sodium and chloride ion. This electrostatic force of attraction is known as your chemical bond, right? And the type of bond that results, the type of force, right, that results as a result of transfer of electrons is known as electrovalent bond, because this is electrostatic attraction, so this is electrovalent bond. Similarly here, sharing of electron has occurred, so there is, here you have this negatively charged electron pairs, you have positively charged nucleus, right? So there is attraction between electron pairs and this nucleus, due to which this oxygen molecule is stable. And the bond that is formed due to sharing of electron, this is your covalent bond. This is your covalent bond, right? So bond that results after sharing of electrons is your covalent bond. Bond that results after transfer of electron is your electrovalent bond, right? So there is another bond which is coordinate bond, right, in which this shared pair of electrons, like it's coming from both the atoms, the shared pair of electrons will come from single atom. Its example is ammonia. We'll do that in future lecture. So how these atoms are acquiring stable gas configurations like those of noble gases, by either transfer of electrons or by sharing of electrons, right? So to acquire stable noble gas configuration, atoms either share electrons or they will transfer electrons, right, to acquire stable electronic configuration. So these are the two ways using which these atoms can acquire stability, right? So to acquire stable electronic configuration, there would be either transfer of electron, right, that will result into electrovalent bond, or there would be sharing of electrons, right, that will result into covalent bond, right? So these are the two ways using which atoms can acquire stable electronic gas, stable noble gas configuration, right? So atoms once have stable electronic configuration like those of noble gases will acquire stability, right? Once these ions, like we have seen, have 8 electrons, they will become stable, right? So now they will not react with one another. That is why H3 combination is not possible. Why? Because in hydrogen molecule, if you see, both these have two electrons, right? So they will not combine with another hydrogen atom, right? Because that will not result into 2 electrons with that atom, right? So H3 combination, like this combination, is not possible because hydrogen atoms already have two electrons. Similarly, He2 is not possible. Why? Only this helium can exist independently, whereas He2 does not exist. Why? Because helium already have 2 electrons, right? So it will not undergo further chemical reaction to form He2 molecule, right? Since it already has 8 electrons, 2 electrons. Similarly, other gases also have 8 electrons, so they will not form diatomic molecules, right? Helium or any other noble gas like neon, they will not form diatomic molecules because the monoatomic molecules already have 2 or 8 electrons, which represents your stable electronic configuration, right? So they do not have to acquire any stability, so they will not undergo any chemical reaction via transfer of electrons or sharing of electrons, whereas other atoms like oxygen, nitrogen, hydrogen, or sodium, chloride, calcium, in all these atoms does not have 2 or 8 electrons in their outermost shell, so they will undergo chemical reaction and exchange. They will undergo chemical reaction via exchange of electrons to acquire octet or doublet, that is 8 or 2 electrons in their outermost shell, to achieve stability. So the reason of chemical combination is to achieve stability, right? And how to achieve stability? by acquiring 8 electrons in their outermost shell. So the reason for chemical combination is to acquire doublet or octet to achieve stability, right? Because we know that every system in the universe tries to acquire stability, and stability in case of atoms can be acquired by achieving 2 or 8 electrons in the outermost orbit, right? So the reason for chemical combination is to achieve stability by acquiring 2 or 8 electrons in outermost orbit, right? That is this NS2 NP6 type configuration. Once they acquire NS2 NP6 type configuration, the atoms will become stable, or NS2 or like in case of hydrogen atom 1s2 configuration, right? So this was Kossel-Lewis theory of Kossel-Lewis theory of stability of atom. They explained the stability of atom using this theory, right? So this is it. Now after this, in this lecture we are clear why chemical combination takes place, right? And we'll see the concept of valency in another video lecture. The valency, if you define from these explanation, valency we know is the combining capacity of an element. Like the valency of sodium here is 1, because only one atom of sodium can combine here, or the one atom of sodium can combine with one atom of chlorine. So the valency of sodium is 1, right? If you look at from the other perspective, it has only one electron, so it will transfer only one electron and combine with one atom of chlorine. So combining capacity is 1. If you look at hydrogen or oxygen, right? In oxygen is combining with one atom of chlorine, right? So if you look at this calcium, in calcium chloride combines with 2 chlorine atoms. Calcium has 2 electrons in its outermost orbit. One it will transfer to one chlorine atom, other it will transfer to other chlorine atom. So here combining capacity of chlorine is, it's 2. It's combining with 2 chlorine atoms, so it has valency of 2. Similarly, chlorine is combining with one chlorine atom only. If you look at this chlorine atom, it's combining with only one calcium atom, so its valency is 1. For this also it's 1, right? So this is the concept of valency, and this theory of Kossel and Lewis is electronic theory of chemical combination, right? We call this theory as electronic theory of valency, right? This theory of Kossel and Lewis is known as electronic theory of valency. Why we call it as electronic theory of valency? Because this is based on electronic concept of atoms, right? Because this is based on electronic concept, so we call it as electronic theory of valency, right? So I hope this is clear. Just know why chemical combination takes place, right? To achieve noble gas configuration of 8 or 2 electrons in the outermost shell, and how this noble gas configuration can be achieved by either transfer of electrons or sharing of electrons, right? Which will result into electrovalent and covalent bond. Now in next video lecture we will look into detailed electrovalent and covalent bond. I hope this is clear. Thanks.